is Mohammed Zamira. My roll number is 219518041. My department is ECB section. Today my topic is expected value of uniform random variable. What is a uniform distribution? A uniform distribution, also called a rectangular distribution, is a probability distribution that has constant probability. This distribution is defined by two parameters, a and b. A is minimum, b is maximum. The distribution is written as u of a comma b. The following graph shows the distribution with a is equals to 1 and b is equals to 3. The graph is shown here. Like all the probability distribution for continuous random variables, the area under the graph of random variable is always equal to 1. In the graph, in the above graph, the area is A is equals to L into H is equals to 2 into 0.5 is equals to 1. Note, in actual science, the uniform distribution is called the De Moivre De Moivre distribution. What is uniform distribution? The uniform distribution is a probability distribution in which the possible outcome from an interval and all subintervals contained in this interval that have the same length are equal likely. If the minimum and maximum possible outcomes are a and b respectively, we have the uniform distribution on a comma b. We denote this distribution as u of a comma b. We can define a continuous uniform distribution on an interval we want. If we use the 0 comma 1 interval, we then obtain the standard uniform distribution u of 0 comma 1. Interestingly, the standard uniform distribution is a special case of beta distribution with parameters 1 comma 1. U of 0 comma a 0 comma a is equals to b of 1 comma 1. In surely we can say that the uniform distribution models the situations where all outcomes are equally likely. Through we have to remember that formally, in the case of continuous distribution, the probability of particular outcome x is always equals to 0. Types the distribution has two types. The most common type you will find in elementary statics is the continuous uniform distribution in the shape of rectangle. However, there is a second type, the discrete uniform distribution. It still resembles a rectangular, but instead of line, a series of dots represent a known a finite number of outcomes. The following graph shows five possible outcomes. Rolling a single die in one example of discrete uniform distribution. A die roll has four possible outcomes: 1, comma 2, comma 3, comma 4, comma 5, or 6. There is 1 by 6 probability for each number being rolled. The graph is shown here. General formula. The general formula for the probability density function PDF for the uniform distribution is f of x is equals to 1 by b minus a for x a greater than equals to x greater than equals to b. A is the location parameter. The location parameter tells you where the center of graph is. B is the scale parameter. The scale parameter stretches the graph out on the horizontal axis. Note the A and B here and to be confused with lower cases a comma b, which is open interval. Uniform CDF. Uniform CDF. The uniform distribution doesn't always look like a rectangular or special case. The uniform cumulative distribution functions adds up all the probability. In the same way, a cumulative frequency distribution adds probability and plots the results, which is a linear graph and not a rectangle. Expected value and variance. The expected value, that is the mean of uniform random variable x is e of x is equals to 1 by 2 a plus b. E of x is equals to 1 by 2 a into a plus b. This is also written equivalently as e of x is equals to b plus a by 2. A is the formula in the minimum value in the distribution and b is the maximum value. Uniform random variable are used to model scenarios where the expected outcomes are equiprobable. For example, in a communication system design, these set of possible source symbols are considered equal probable and therefore modeled as a uniform random variable. The uniform distribution is the underlying distribution for an uniform random variable. A continuous uniform random variable denotes x by sim. Take continuous values within a given interval a comma b with equal probability. On the other hand, a discrete random variable generates discrete values that are equally probable. The underlying discrete uniform distribution is denoted as where is a finite. set of discrete elements that are equally probable as described by the probability mass function. The probability mass function f of x is equals to where x belongs to s1, s2, s not. Otherwise, f of x is equals to in where x belongs to s1, s2, or s not. Otherwise, there exist several methods to generate discrete uniform random variable. The uniform distribution is characterized as following. Definition: let be a continuous random variable, or let it support be a closed interval of a real number. We say that has a uniform distribution on the interval if the only if the probability density function if fx of x, a random variable having a uniform distribution, is also called as uniform random variable. Sometimes we also say that it has a rectangular distribution, or that is a rectangular random variable. Variance: the variance of uniform random variable is f of x. Moment generation function: the moment generation function of uniform random variable is defined for any mx of t 1 by u of minus l of t expect t of u. Characteristic function: the characteristic function of uniform random variable x is psi x of t. Distribution function: the distribution function of uniform random variable is f of x is equals to 0 if x is greater than 1, x minus 1 into u minus 1. If L is greater than or equals to x, x is greater than or equals to u. If x is less than u, 1. You can solve these types of problems using these steps above, or you can use the formula for finding the probability of for a continuous uniform distribution p of x d minus c by b minus a. This is also sometimes written as p of x is equals to x2 minus x1 by b minus a. D and C, x2 minus x1, are the and upper lower bounds of the area you are trying to find. You get exactly the same answer as if you would follow the steps above. If formulas work for you are great. Personally, I find it easier to visualize these problems as trying to find an area inside a rectangular. Otherwise, if I have just got another formula to memorize. This page covers uniform distribution, expectations, and variance, poor expectations, and cumulative distribution function. A continuous random variable x, which has a probable density function, gives by f of x. F of x is equals to 1 by b minus a for xb. F of x is equal to 0. X is not between a and b, follows a uniform distribution with parameters a and b. We write x is equals to u of a comma b. Remember that the area under the graph of random variable must be equals to 1. Expectations of variance: if x u of a comma b, then x of 1 by a plus b. Variance: 1 by 12 b minus a whole square. Proof of expectations. Cumulative distribution function. The cumulative distribution function can be found by integrating the PDF between 0 and 3. F of t is equals to integrated 1 by b minus a dx from t is equals to t minus a by b minus a. Probability density function distribution, cumulative distribution function. The graphs are given below. Probability density function formula. Probability density function formula, that means for only constants a comma b, the functions f of x gives us the probability density at point x if the limits of probability of the interval divided by the length of the interval as the length of the interval goes to 0. Remember that is differentiable at x. Conclusion: the uniform distribution defines equal probability over a given range for a continuous distribution. For this reason, it is important as a reference distribution. On one of the most important applications of the uniform distribution is the generation of random numbers. The probability distribution are a common way to describe and possibly predict the probability of an event. The main point is to define the character of the variables whose behavior is trying to describe through probability, discrete or continuous. Thank you for giving me this wonderful opportunity.